We are diving into a stack of high-octane research today, focused entirely on, well, the world's most consumed substance after water.
Caffeine.
Caffeine. And this isn't just about, your morning habit. We're really framing caffeine as one of the few scientifically proven, legally available ergogenic aids, a genuine performance enhancer.
And that's really the core mission of this deep dive. I mean, for anyone who relies on caffeine for a performance boost, whether you're an athlete, a student prepping for exams, or just, a highly productive professional, this information is absolute gold.
Right.
We're looking at these comprehensive studies that were designed to answer one single critical question.
Which is?
Does your daily coffee consumption, your high habitual use, does that negate the acute ergogenic effects of a pre-workout dose? We're here to find that strategic sweet spot.
The sources you brought today, they rely heavily on this massive study that gives us, I have to say, surprisingly definitive answers. About dose, about gender, about consumption habits.
Yeah.
And here is the immediate impactful takeaway, the thing you need to know right now. For about 80% of the world who regularly consumes caffeine, if you want a performance boost in the gym or, the boardroom, you need to hit a very specific high dose.
A very specific dose.
And that dose is basically non-negotiable if you are already fatigued. We're going to show you exactly what that dose is and how it functions.
And we've got the receipts. This research used a really rigorous protocol, randomized, crossover, double-blind.
Gold standard.
The absolute gold standard. They tested athletes based on their defined habitual caffeine consumption, low, moderate, and high users. And then we get to compare their performance across 4 precise conditions.
Placebo,
then 1.5 milligrams per kilogram of body weight, 3 milligrams per kilogram, and 6 milligrams per kilogram. This framework, it lets us perfectly isolate the impact of tolerance versus the power of an acute dose across all these different physical and cognitive tasks.
Okay, so before we get to the data, let's start where every great story begins. History. We're talking about 1-3-7 trimethopsantine. Where does the legend start for this remarkable chemical?
Well, the origin story is wonderfully mythical, as it often is for these foundational substances. One account traces the discovery way, way back to the Chinese Emperor Shen Nung.
When was this?
Supposedly around 2737 BCE. Legend says he was boiling water when leaves from a Camellia sinensis plant.
So tea leaves.
Tea leaves, exactly. They drifted into his pot, and he found the resulting infusion to be incredibly invigorating.
And then you've got the coffee legend, which I think feels slightly more relatable. It involves a restless herd.
Yes, the tale of the Abyssinian shepherd, Khaldan. This was sometime around 850 AD. He noticed his goats became incredibly energetic, just refusing to sleep after they ate these certain bright red berries.
He must have thought something was wrong with them.
I'm sure. But he tried them himself, and, feeling that immediate surge of energy, he realized he'd stumbled upon something powerful.
The coffee bean.
The coffee bean.
I just appreciate that for thousands of years, people have been accidentally trying to get to sleep and finding something that does the exact opposite.
It's a recurring theme.
So let's talk chemistry. This substance is found in over 60 plants, tea, cocoa, cola nuts. But what is the primal reason it even exists in those plants?
That's a great question. And the sources make it really clear. Caffeine is fundamentally a defense mechanism.
Defense.
It's a natural chemical toxin. Plants synthesize it for self-defense. In high concentrations, it's toxic, even deadly, to many of the smaller insects and organisms that might try to eat the plant's leaves or its seeds.
So it's basically a form of chemical warfare.
It is.
Yet it has this incredible, almost symbiotic relationship with some species that actually helps the plant thrive.
And that's the evolutionary brilliance of it, right? Studies have shown that for essential pollinators, like honeybees, trace amounts of caffeine in the nectar actually provide a cognitive advantage.
An advantage for the bee.
For the bee. It subtly enhances the bee's memory of that source, making them more likely to return to that specific plant, which, dramatically improves the plant's reproductive success. It essentially overrides that general toxicity factor.
Speaking of its effect on the nervous system, there is a famous, really powerful visual analogy that demonstrates just how potent this molecule is. The 1995 NASA study involving spiders really drives this home.
Oh, it's the perfect illustration of central nervous system disruption. It's almost unsettling to look at. You take a drug-naive spider, and it spins a web that is, symmetrical, highly organized, structurally sound. It's a marvel of engineering.
A perfect web.
The perfect web. Then you give that same spider caffeine.
And what happens?
The resulting web is severely irregular, often broken, and practically unrecognizable. Just a chaotic mess.
So the takeaway isn't that coffee makes you a bad architect.
No. The takeaway is that this substance, which we treat so casually, exerts immense power over fundamental, complex neurological processes.
Let's move from that visualization to the actual biological wiring. We need to follow the caffeine molecule from your cup all the way to the peak of its performance effect. So how does it get into the system, and how fast is that process?
It's absorbed remarkably quickly. Because it dissolves easily in both water and fat, it crosses biological membranes very efficiently.
So it doesn't need much help getting in.
Not at all. It's absorbed primarily in the small intestine, and the concentration in the plasma, your bloodstream, usually peaks between 45 to 90 minutes after you drink it.
And that timing is absolutely critical when we talk about using it strategically for competition.
Crucial. You have to time it right.
Once it's circulating, the liver gets involved, right? It starts metabolizing it into these active compounds.
Correct. The liver's cytochrome P450 enzyme, it goes to work breaking down the caffeine molecule. It creates 3 major metabolites, paraxanthine, theobromine, and theophylline, which all have their own pharmacological activities, and they contribute to the overall stimulating effect.
So it's not just the caffeine itself doing the work.
It's the whole family of molecules. And the half-life, which is the time it takes for half the dose to be cleared from your system, averages between 3.5 to 5 hours.
But that can vary a lot, I'm guessing.
No, it's highly individual. It's influenced by everything from your genetics and the dose you took to, crucially for our discussion today, your habitual consumption level.
Okay, let's look at the primary mechanism then.
Yeah.
The reason you feel awake. Adenosine antagonism. This really is the centerpiece of its ergogenic power.
Absolutely. The simplest way to think about it is that adenosine is the body's natural brake pedal.
The brake pedal, I like that.
Adenosine is a neuromodulator that builds up in your brain the longer you're awake. It binds to these receptors, specifically A1 and A2A. And when it binds, it slows down neural activity, it promotes sleep, and it signals to your entire system, hey, we're running on empty, it's time to rest.
And caffeine is structurally almost identical to adenosine.
Almost identical.
So caffeine just jumps the line.
Precisely. It's an antagonist. It fits perfectly into those adenosine receptor sites. But, and this is the key, it doesn't activate them. It just sits there and blocks adenosine from binding.
So you could have these huge levels of adenosine signaling fatigue, but caffeine has essentially disconnected the signal wire.
You've got it. And that's what enhances alertness, delays the subjective perception of fatigue, and just ramps up the central nervous system.
That delayed perception of fatigue is one huge advantage. What about the hormonal cascade that follows this CNS stimulation?
Well, the activation of the CNS triggers the release of various hormones from the adrenal glands. We see a significant spike in catecholamines.
Adrenaline and noradrenaline.
Right, adrenaline or epinephrine and noradrenaline or epinephrine. But also cortisol and beta endorphins. This hormonal surge, it has multiple performance benefits.
And what are the effects we actually feel during performance?
2 main things, really. First, you get improved psychomotor activity and mood. You just feel more motivated and your reaction time improves. And second, and this is critical for endurance and effort capacity, is the reduction in the ratings of perceived exertion, your RPE.
So things feel easier than they actually are.
Exactly. Objectively, your muscles might be working at 90% of your max heart rate. But subjectively, because of these CNS and hormonal effects, it only feels like 70%. That psychological buffer is an incredibly powerful tool in a competitive setting.
That reduction in RPE alone can be the difference between winning and, well, quitting.
It really can.
Let's also touch on another mechanism, the one related to energy efficiency, lipolysis.
Right. So the stimulation of the sympathetic nervous system also leads to increased lipolysis, which is just the breakdown of stored fat into usable energy into free fatty acids.
And why is that so valuable?
During prolonged endurance exercise, this mechanism is extremely valuable because using more fat as fuel, especially early on, spares your finite glycogen reserves in the muscle.
Your carb stores.
Your carb stores. Studies consistently show increased muscle fat oxidation and a corresponding conservation of glycogen, which just allows you to sustain a high pace for much longer.
Okay, so finally, let's consider the direct effect on the muscle tissue itself. This is often the most misunderstood mechanism, the sodium-potassium ATPase effect.
This brings us right out of the brain and into the actual motor unit. During intense maximal effort exercise, a lot of muscle fatigue results from disruptions to the muscle cell's electrical balance.
Things get out of whack.
They do. Specifically, there's an outflow of potassium, K+, from the muscle cell, which then accumulates outside the cell membrane. And this affects the resting membrane potential, making it harder for the muscle to be excited and contract again.
So the pump system that resets everything gets tired and jammed up.
Precisely. And caffeine is believed to increase the activity of the sodium-potassium ATPase enzyme, the NA-K ATPase pump.
And that's the thing that fixes the balance.
That's the enzyme responsible for actively pumping sodium ions out and potassium ions back into the cell, maintaining that vital electrical gradient. By activating this pump, caffeine helps the muscle cell maintain its excitability. It ensures the switch stays ready to fire, potentially contributing to enhanced and sustained muscular contraction.
Wow, so caffeine isn't just a mental hack. It's not just in your head. It's physically helping the muscle fibers maintain high-quality contractions by stabilizing the cell environment during duress. That's a really potent, multifaceted ergogenic profile.
It is. It works on multiple levels simultaneously.
Which brings us perfectly to the study framework. We know caffeine works, but the big question is, does it work for you, the person who drinks a latte every single morning? This study meticulously isolated that variable. Tell us about the athletes and how they were grouped.
Okay, so the research recruited 69 highly trained, competitive male and female athletes.
Not beginners.
Definitely not. They were specializing in team sports like soccer, handball, rugby, and basketball. These are people who regularly performed strength training and sprints, the very tasks we're about to see them tested on.
And the grouping was based solely on their established, self-reported daily caffeine intake, right?
Correct. Participants were strictly categorized into 3 distinct habitual consumption groups, which is essential for gauging their tolerance levels.
First up, the low habituation group.
These athletes consumed a daily average of only 30 to 40 milligrams of caffeine. I mean, they were essentially caffeine naive or very, very light users. A cup of green tea, maybe?
Then you have the moderate habituation group.
Their consumption was moderate, averaging around 140 to 160 milligrams per day. This is roughly equivalent to 1, maybe 2 cups of brewed coffee.
Probably where a lot of people fall.
A very common range.
And finally, the high habituation group.
Right. These were the heavy users.
Yeah.
They were consuming substantial amounts daily, averaging between 370 and 385 milligrams per day.
So that's like 4 to 5 strong cups of coffee or a couple of energy drinks.
Exactly. And analyzing these 3 distinct groups against a range of acute doses is really the central innovation of this research.
Let's talk about the rigor of the protocol because it's pretty impressive. They used a randomized crossover double-blind protocol.
Yeah.
For our listener, why is this specific design so important, especially in supplement research?
Well, this design is the gold standard because it eliminates almost all forms of bias. Randomized ensures that the order of the conditions doesn't skew the results.
So it's not like everyone did the hard dose last.
Exactly. Crossover is vital here. Every single athlete participated in all 4 conditions.
So they acted as their own control.
They acted as their own control. Any difference in performance between, say, their placebo day and their 6 milligram per kilogram day must be due to the caffeine itself, since their genetics and base fitness are held constant.
And double-blind.
That means neither the athlete nor the staff testing them knew which dose was being administered on any given day. That eliminates expectation bias, the placebo effect.
They also controlled for biological timing, right? Testing was always in the morning after an overnight fast.
That's necessary to eliminate confounding variables like energy levels from previous meals or performance variations due to circadian rhythm. All the testing occurred between 7 and 9 a.m.
Okay, now let's get into the crucial dosing. They weren't just testing pure caffeine pills, they were testing caffeinated coffee. How did they ensure that the results were due only to the caffeine and not to the thousands of other compounds in coffee, like antioxidants or polyphenols?
This is a really meticulous detail, and it separates great research from just good research. To isolate the caffeine effect, they administered all 4 conditions, placebo, 1.53, and 6 milligrams per kg, using the exact same total amount of coffee solids.
That seems impossible to balance when you're testing varying doses. How do they actually manage that?
It's clever. They mixed specific amounts of a highly concentrated caffeinated coffee powder and a decaffeinated coffee powder. They used these to hit the exact target doses while ensuring the total mass of the coffee solids was identical across all 4 conditions.
So everyone got the same amount of coffee stuff.
Exactly. 0.16 grams per kilogram of body weight. This powder was then mixed into 600 milliliters of hot water. So the participants experienced the same taste, the same temperature, the same presence of non-caffeine compounds. The only variable that changed was the amount of that active molecule, 1,3,7-trimethylxanthine.
That is fantastic control. And the ingestion timing.
Ingestion happened precisely 60 minutes before the physical testing began. This window is calibrated to ensure that the rigorous, high-effort protocol aligns perfectly with that known peak plasma caffeine concentration we talked about, maximizing the potential ergogenic effect.
Let's outline the exhaustive test sequence. It was clearly designed to push the central nervous system, which is key to interpreting the results later.
Oh, it was a true test of stamina and recovery. It was designed to mimic the fatigue you'd encounter in a long training session or late in a game.
So what do they do first?
First, they took a baseline measure of cognitive performance using a demanding test called the flanker task.
Okay, baseline brain function.
Then came the coffee ingestion and that 60-minute wait. After the wait, they measured cognitive performance again.
Post-ingestion, but pre-fatigue.
Exactly. And then the heavy lifting started. Squat 1 rep max for maximal strength, followed immediately by squat endurance. So, repetitions to failure at 60% of their 1 rep max.
And then they move to the upper body.
Right. Bench press 1 rep max, followed by bench press endurance, same protocol, reps to failure at 60%.
So by this point, they're already pretty gassed.
Oh yeah. And finally, after all that strength and endurance work, they did the 15-second revised Wingate sprint test, which measures peak and average power.
And the final measure.
The final measure was cognitive performance, measured one last time, post-protocol, under heavy fatigue. The sequence just progresses from maximal strength through muscular endurance and finishes with high-intensity anaerobic power, all designed to induce high levels of central fatigue before that final performance assessment.
Let's dive into the physical results, and we have to start with the biggest lifts.
Right.
The single maximal effort, the 1 rep max. What's so striking here is a massive null effect across all groups.
That's a key structural finding that often surprises people. The research showed unequivocally that caffeinated coffee at any dose tested 1.5, 3, or 6 milligrams per kg did not significantly increase maximal strength.
For either lift.
For either the squat or the bench press, no change in 1 rep max.
Why do you think that is? I mean, we just discussed how caffeine stimulates the CNS and aids muscular excitability, yet it doesn't help you lift heavier once.
This tells us something really fundamental about the mechanism of maximal strength versus endurance. A single 1 rep max lift is defined primarily by muscle cross-sectional area, your technique, and motor unit recruitment, which are already maximally activated in a rested state.
So you're already giving 100%.
You're already firing on all cylinders. The ergogenic benefits of caffeine blocking adenosine, reducing RPE, enhancing that NAK pump activity, they're most critical when the system is struggling against fatigue or when you're trying to maintain submaximal output over time.
So if you're rested and you're going for an all-time personal best squat, the caffeine might make you feel more motivated, but it's not going to physically add 10 kilos to the bar because the muscle is already capable of full recruitment.
Precisely. The effect is less about increasing your absolute strength ceiling and more about delaying the arrival of fatigue, which causes that ceiling to drop during a workout.
Okay, that's a crucial distinction. Now, let's transition to muscular endurance, where we see clear, profound benefits, but also major differences between the upper and lower body. First, upper body endurance, the bench press to failure. Did caffeine help there?
No. Another null effect, no significant increase was observed in upper body muscular endurance at any dose or any consumption frequency.
So even the highest dose did nothing for bench press reps?
Nothing. The high dose was just as ineffective as the low dose or the placebo for bench press repetitions.
Okay, so if the same athlete took 6 milligrams per kilogram and saw no increase in their bench press endurance, why would they see a huge increase in their squat endurance?
The expert analysis suggests the selectivity is driven by two main factors: muscle size and receptor density.
More muscle means more effect.
Essentially, yes.
Yeah.
The ergogenic effect relies heavily on adenosine receptor antagonism and that subsequent hormonal cascade. Larger muscle groups, the quadriceps, hamstrings, and glutes involved in the squat, have vastly more muscle mass, and consequently, they have a higher number of adenosine receptors and a greater metabolic requirement than the comparatively smaller muscle groups used in the bench press, like the pecs and triceps.
So the larger the engine, the more responsive it is to caffeine's chemical fuel.
That's a great analogy. The pharmacological window for performance enhancement seems to be much wider and more accessible in the lower body musculature than the upper body.
Okay, and here's where it gets really interesting. The lower body endurance results show a clear, measurable example of dose-dependent tolerance based on daily habit.
This is the definitive answer to the question. Does my daily habit matter? Yes. It matters tremendously for submaximal, repeatable effort.
Let's start with the low and moderate habituation groups. The people drinking little to no coffee, or maybe just 1 cup a day.
For athletes in the low and moderate consumption groups, their performance in the squat endurance test significantly increased with both the 3 milligram per kilogram dose and the 6 milligram per kilogram dose.
So for them, a relatively moderate dose delivered a statistically significant benefit.
It did. If you have an 80-kilogram athlete, that's just 240 milligrams, a decent-sized cup of strong coffee, and that was enough to boost their reps.
But for the high habituation group, the nearly 400 milligram daily consumers, their system is essentially desensitized.
Exactly. They have achieved functional tolerance. For the high habituation group, their performance only increased significantly with the maximal dose, 6 milligrams per kilogram.
So the 3 milligram dose did nothing for them.
Nothing. The moderate 3 milligram per kilogram, which worked fine for everyone else, was completely ineffective for boosting their lower body muscular endurance. This confirms that daily high consumption raises the functional threshold required to see an acute performance benefit. They need a huge hit just to get past their own baseline.
That is a critical strategic takeaway. If you drink coffee all day, every day, you are essentially neutralizing the effectiveness of standard doses of pre-workout supplements.
You absolutely are. The study shows that the acute benefit of that 3 milligram per kilogram dose is simply returning the high habitual consumer to a placebo-like performance level relative to their non-caffeinated baseline. They need the 6 milligram per kilogram dose to achieve a true, measurable ergogenic gain.
Okay, now let's move to the Wingate Sprint test. This test is unique because it assesses maximal anaerobic power, and it was performed last when the athletes were already heavily fatigued from the preceding strength and endurance protocols.
The Wingate results were striking because they offered a universal prescription for high-intensity work under duress.
And what did they find?
Sprint performance, both peak power and average power, was significantly enhanced only by the high dose.
6 milligrams per kilogram again?
6 milligram per kilogram.
And the nuance here is that this benefit was seen across all consumption groups, right? It was powerful enough to override tolerance completely.
That is the headline. The 6 milligram per kilogram dose was potent enough to boost the performance of the low, the moderate, and the high habitual consumers when they were performing explosive, high-intensity anaerobic work. This is the fatigue override in action.
Why does 6 milligram per kilogram suddenly become the magic number for everyone when they're tired?
Because the preceding fatigue pushed the central nervous system to its absolute limit, the body had already activated countless adenosine signals, it had depleted glycogen, it had taxed those NAK pumps. The 6 milligram per kilogram dose provides the necessary massive surge of CNS stimulation and catecholamines to overcome both the acquired daily tolerance and the accumulated acute fatigue from a workout.
So this dose is essential when performance is required late in a demanding event.
Precisely, like the final period of a rugby match or a last-minute defensive sprint in basketball.
Performance isn't purely physical, though, especially in complex team sports. Decision-making, selective attention, quick reaction time under pressure, those are equally important. Let's look at the cognitive performance measured using the flanker task.
Right, so the flanker task is a behavioral task that measures your ability to respond quickly to a central stimulus while ignoring distracting stimuli around it.
So it's a test of focus.
A pure test of selective attention and inhibitory control, the mental skills that degrade rapidly under physical fatigue. And the cognitive results, they perfectly mirrored the sprint findings.
Meaning only the maximal dose was effective.
Exactly. Only the high dose, 6 milligrams per kilogram, significantly improved overall cognitive performance, both in terms of accuracy and, more profoundly, in reaction time. The lower doses, 1.5 and 3 milligram, offered no statistically significant cognitive edge over the placebo.
The timing is critical here too. Since cognitive performance was tested after the athletes have been thoroughly exhausted by squats, bench presses, and the Wingate sprint, this 6 milligram dose is really acting as a cognitive restorer.
It's the ultimate brain fuel under duress. The 6 milligram per kilogram dose seems necessary to maintain or restore complex cognitive function when the CNS has been severely taxed. This has huge implications for game time decisions, especially in endurance or team sports where you need a clear head when your body is failing.
So better decisions late in game.
And faster decisions. The quickness in inhibitory control, your ability to stop one action and initiate another, more appropriate action, was profoundly improved by that high dose.
Now for the fascinating disconnect. The physiological stability results. We're talking about heart rate and ratings of perceived exertion. The objective performance went up, but what did the athletes actually feel?
The results were remarkably consistent with established caffeine literature, which shows this disconnect. First question, when the athletes took any of the caffeinated doses, did their heart rate jump?
You'd think it would.
You would, but no.
So none of the caffeinated coffee doses caused a significant change in heart rate, whether at rest or immediately after the maximal exercise protocols.
None whatsoever. Heart rate was statistically unchanged by 1.5, 3, or 6 milligrams per kilogram. The cardiac system was stable.
Okay, that's important. And what about the subjective measure of how hard the exercise felt, the RPE? Did they feel like they were working harder when they hit those higher endurance and sprint numbers?
Also no. RPE values, which were measured using the 6 to 20 Borg scale, were not significantly affected by any dose of caffeinated coffee during or after the maximal exercise tests.
So they performed better, but they reported the same level of perceived effort as the placebo group.
Exactly.
That is the ultimate competitive advantage, isn't it? If we connect this to the bigger picture, caffeine enhances objective performance boosting sprints, increasing lower body reps, but it does it without increasing the subjective feeling of effort or increasing cardiac load during maximal work.
That is the definition of a legal, highly effective ergogenic aid. It allows the athlete to strategically bypass the fatigue signals that would otherwise dictate their effort level, all while keeping their conscious mind convinced they are operating within their comfort zone.
Given how profoundly effective caffeine is, we have to address its legality. I mean, why isn't it illegal in competition? Let's discuss its current status with the World Anti-Doping Agency, WADA.
Caffeine's journey with WADA is a perfect case study in the intersection of science and sport regulation. It was actually on the banned list for many years.
I remember that.
It started in 1984 with a threshold for doping set extremely high, 12 micrograms per milliliter in urine.
Which would require a massive amount of coffee.
A huge amount. But WADA made a crucial decision and removed it from the banned list in 2004. And this was largely because comprehensive scientific research proved that the performance benefits occur at dose levels far below that former doping threshold.
So you could get a legal, measurable performance boost without getting anywhere near the old limit.
That's it. So it remains a proven ergogenic, but it's completely legal. It does remain on the WADA monitoring list, which is primarily for scientists to track patterns of use and ensure that athletes aren't combining massive doses with other prohibited substances.
But it's not a prohibited substance.
Not prohibited. The irony remains that one of the most effective and accessible performance aids is fully legal.
This research focused specifically on caffeinated coffee. But if timing is everything, getting that peak plasma concentration to align with performance, do the various forms of caffeine matter? Capsules, gum, liquid coffee.
Oh, they matter significantly because the rate of absorption varies. Coffee, as studied here, requires that 45 to 90-minute window because it has to be processed and absorbed through the stomach and the small intestine.
And capsules are similar.
Pure anhydrous caffeine capsules are also effective and deliver a precise dose, but they follow a similar timeline.
What about the forms designed for more rapid absorption?
That's where you get into things like caffeine chewing gum. That absorbs the fastest, sometimes within 5 to 15 minutes.
How does that work?
The caffeine molecules enter the bloodstream through the buccal tissues in your mouth, bypassing the digestive system entirely. This is a strategic advantage for last-minute timing adjustments, but it's also a risk.
A risk how?
If you take the gum too early, your peak effect might pass before your short, explosive event even begins. For this study's protocol, which was multi-hour and exhaustive, the 60-minute pre-ingestion for coffee was optimal. But for a quick single-event sprint, you might time a capsule for 30 minutes out, or the gum for just 5 minutes out.
So if an athlete has strategically identified their required dose, 3 milligrams per kilogram for low consumer, 6 for a high consumer, how does caffeine strategically stack with other proven ergogenics? This seems crucial for maximizing benefits.
This is where we shift from individual effect to systemic synergy. Caffeine works exceptionally well with other supplements because they utilize fundamentally different complementary mechanistic pathways to combat fatigue.
So you're attacking the problem from multiple sides.
Exactly.
Let's start with a really common one, carbohydrates. Carbs.
Right. The combination is powerful for both endurance and recovery. Caffeine promotes fat oxidation, as we discussed, which helps to spare muscle glycogen. So if an endurance athlete is taking carbs during their event, combining that with caffeine means they're getting a sustained energy source from the carbs, while the caffeine optimizes their internal fuel mix, leveraging fat for longer.
And what about post-exercise recovery?
Post-exercise, the stacking is even more robust. Studies have shown that co-ingesting caffeine and carbohydrates significantly enhances muscle glycogen resynthesis.
It replenishes your stored energy faster.
Much faster than carbs alone. The suggested mechanism is that caffeine enhances the responsiveness of the muscle cell to insulin, which speeds up the uptake and storage of glucose from the bloodstream.
That would significantly accelerate recovery for multi-day events or just high training volume.
Absolutely.
Now let's look at the metabolic buffers. Beta-alanine and sodium bicarbonate. These are really popular for high-intensity athletes.
This is a highly strategic combination. Recall that high-intensity exercise is limited by two major factors. Central nervous fatigue, which is the adenosine buildup that caffeine targets.
Great.
And metabolic acidosis, which is the lactic acid buildup that the buffers target.
So they're solving two different problems at the same time.
Exactly. Beta-alanine increases muscle carnosine levels, and sodium bicarbonate neutralizes acidity. They act as pH buffers. They help prevent the muscle environment from becoming too acidic during repeated maximal effort, allowing the muscle to sustain high power output for longer.
And when you stack that with caffeine?
When you stack this with caffeine, which is enhancing the neural drive and reducing RPE, you are simultaneously increasing the Burroughs signal from the brain and reinforcing the muscle's ability to resist the metabolic consequence of that maximal effort. This synergy has been shown to result in superior performance in repeated high-intensity sprints.
That makes the dose-response data from this study incredibly actionable. Let's circle back to the core finding. The 6 milligram per kilogram dose was necessary to see physical and cognitive benefits in the high habituation group, and it was universally required to boost performance when fatigued. So what does this all mean for training and competition timing?
So what does this all mean for you? If you are a high habitual consumer, 6 milligrams per kilogram is the required therapeutic dose to overcome the functional tolerance you have built up. And this is particularly crucial when you're performing highly anaerobic tasks under duress.
Let's put this into a game scenario.
Yeah.
Imagine a rugby player who's a high consumer.
Okay, so that player might be running on fumes in the 70th minute of a match. They're mentally exhausted, their body is screaming stop because of all the adenosine buildup.
Right.
If they had taken a 3 milligram per kilogram dose before the game, they might have maintained baseline function, but they're not going to get the boost needed to perform that final explosive tackle or breakout sprint.
But if they hit the 6 milligram per kilogram dose,
If they hit the 6 milligram per kilogram dose 60 minutes prior, they are accessing that performance reserve. It's allowing them to make a clear-headed decision and execute that high-power effort effectively, precisely when the competition expects them to fail.
and the study's protocol explicitly created this duress by scheduling the Wingate sprint test dead last. That wasn't accidental. It was a simulation of late-game fatigue.
It was a test of resilience. The data strongly suggests that the 6 milligram per kilogram dose acts as the necessary neurochemical override button when the body is systemically exhausted. If your job, your sport, or your training demands peak output when you are already tired, that high dose is the prescription revealed by this data.
And for the low consumer, the one who benefits from 3 milligram per kilogram for endurance, strategically, they might save the 6 milligram per kilogram dose for the most competitive or demanding training days to maximize its impact and avoid building unnecessary tolerance.
That's the smartest way to use the data. Don't use the maximum effective dose if a lower dose is sufficient, especially if you're a light consumer, because tolerance acquisition happens very quickly.
This deep dive has really peeled back the layers on how our daily coffee habit interacts with acute performance demands, giving us surprisingly precise, actionable data. Just to summarize the most important takeaways for everyone listening.
Well, we confirmed that maximal strength, your 1-rep max, is unaffected by caffeine ingestion.
Right, no change there.
We also learned that upper body endurance is largely immune to caffeine's benefits, likely due to muscle size and receptor density. The benefits for lower body endurance, however, are strongly habituation dependent.
Low and moderate consumers get a boost from 3 and 6 milligrams per kilogram.
But the high consumers, they need the maximum 6 milligram per kilogram dose just to see a true ergogenic benefit.
And that high dose, the 6 milligrams per kilogram, is the universal performance booster. It was the only dose that significantly enhanced sprint power and cognitive function, and it overrode daily consumption tolerance across all groups, particularly when the body was heavily fatigued.
And crucially, as we said, none of these objective gains increase the athlete's subjective feeling of effort or their heart rate.
Which leads directly to a final, provocative thought for the listener and for future research.
The current study measured sprint performance and cognitive function only in a highly fatigued state.
At the end of that exhaustive multi-hour protocol.
Exactly. And this makes the 6 milligram per kg result seem like the minimum requirement, the only thing that works.
But what if you're a rested athlete?
That's the question. Does an athlete really need the high dose, the full 6 milligram per kg, if they're performing that sprint or that cognitive task in a completely rested state, at the beginning of a competition or a training session?
So the optimal dose for a rested athlete might actually be lower.
It suggests that possibility. Perhaps 3 milligram per kg is perfectly fine when you're fresh, which would allow you to save that maximal 6 milligram per kilogram dose exclusively for those late-game scenarios when systemic fatigue needs to be powerfully overcome.
The ultimate strategic reserve. A fascinating angle for us to keep track of as the research evolves. Thank you for joining us for this deep dive into the chemistry, history, and optimal strategic use of the world's favorite ergogenic aid.